We're waiting for some additional people to join, and we will start in a minute. Okay. I'd like to go ahead and get started. Introduce myself, Mark DeMail, Chief Revenue Officer and SVP of Delivery for Svitla Systems. Svitla Systems is a global IT solutions partner. We work with over 125 different companies around the world, providing resources out of Eastern Europe, US, Mexico, Costa Rica, and India for those clients. We do anything from web development, mobile, data, cloud migration, modernization, on the development and support side. One of the things that we are a select AWS partner. We have over 75 clients that we currently work in their AWS environments, either providing part of the team helping with the migration, working on application modernization, or building new applications or features within their AWS environments. What that has is given us some experience and led to us creating our own specific AWS practice, which 𝐓𝐞𝐞𝐞𝐛𝐮 Phillips leads for Svitla. 𝐓𝐶 himself has been a senior DevOps and architect, and he actually worked for me when I was CIO, CTO of TracFone Wireless for 7 years. During that time, he was managing over 1,500 servers, running a telephone company with over 32 million customers. And any of you know the complexity of telcos. He was able to deal with all the complexity and migration from a data-centric environment to a cloud environment. He is as I said earlier, he is our AWS practice lead, and he's currently working with a couple of clients on very large, high transactional volume, large data sets, and how they're going to scale within the cloud for the millions of users that these companies are trying to board on through their applications. And with that, I will turn it over to 𝐓𝐶 Phillips. At the end of the session, we will have a brief Q&A. So if you have any questions you would like to pose to us, feel free to type them in the chat room. Thank you.
Thank you, Mark. Appreciate it. Thank you for the kind words. Hello, my name is 𝐓𝐶 Phillips, lead solution architect here at Svitla. It's a pleasure to talk to you today. Today, specifically, I want to talk to you about application modernization on AWS. What does that really mean, application modernization? A lot of companies, whether they're enterprises or even startups or small, medium businesses, have a lot of legacy components or components that aren't necessarily optimized properly to work on the cloud. Now, here at Svitla, we are experts at this, and we've been doing this for a long time. As Mark said, we're a select AWS partner, and we've taken many clients through this process. And I just want to highlight some things that we've learned over the years in our learnings and in our helping our clients through their journey. But first, I'd like to talk to you about what are the symptoms of legacy development culture. What is a legacy development culture? Typically, you have monolithic applications, large databases on-prem, or maybe not necessarily on-prem. They give you the opportunity to find a good mix of, features and, businesses opportunities for your clients. But the problem with that is there's some problem with that. Obviously, long release cycles, operational issues, recurring bugs. Now, what does this truly mean in a real context? In a real context, that means you have a longer time to market for your features. Now, what does that end mean to your business? That means you're behind. And if you're behind, you're not competing and you're losing business. And if you're losing business, you got a problem. And specifically, long release cycles, operational issues, recurring bugs make for degraded software and make your systems not stable. And as time goes by, unstable systems give you a bad reputation, bring low morale to the people who work for you, and it gives you a low image with your customer. And when the customer doesn't like you anymore, they look for replacements. And in business, you can't have your customer look for replacements. So in today's very competitive world, how do digital businesses keep their advantage? And why do they need to keep their advantage? Like I said before, they have to keep their advantage because they need to keep their customers, because if they don't keep their customers, their business will die. And in order to keep your customers in today's modern world, you must innovate. You must constantly innovate. You must be constantly pushing the edges of how your applications work, the features you bring to your customers, and how you take your technology. And this picture really accurately describes it. It is a flywheel. You have to experiment, get feedback on that, and that should bring more ideas to allow for more experimentation. This is the innovation cycle. If you're not constantly doing this, if you're not in this constant cycle, even for the smallest features, you will be behind. And customers notice if your product hasn't changed. Customers will notice that, hey, this looks the same as it was 6 months ago or a year ago. What are these guys doing? They're just taking my money and they're not giving me new stuff. Because customers are always looking for new stuff. Not only customers are always looking for new stuff, your staff is looking for new things to do. And if you can't keep your staff motivated, you're not going to keep your staff. And if you can't keep your staff, you're constantly hiring new people and you're falling into the same cycle again. People don't know how your legacy apps work. They have to learn. The cycle gets longer and longer and longer. The quality goes down because people just don't know how they run. So if you're not constantly innovating, if you're not constantly changing, you're going to lose customers, you're going to lose employees. And that's a double-edged sword. Truly the goals of modern development practice. And this is the goal for pretty much any business at this point right now. Shorten the time from idea to production. Minimize risks. They go with slow development and create continually improving systems. As I said, you've got to shorten the time from idea to production because in a traditional, enterprise, business comes up with the idea, they've fleshed it out, it gets into the IT cycle, and if it doesn't get out fast enough, the business is going to lose their market share. Now in an enterprise, Maybe, let's say it's not necessarily the most collegial environment. That could lead to a lot of friction between the business and IT. So as an IT organization, as an IT personnel, you have to be able to take those ideas quickly, integrate them, analyze it, and get it into production so the business can make money. Because in the end of the day, that's what it's all about. But at the same time, you need to go fast. You have to minimize the risks of going fast, right? In a traditional old style environment, there would be, in a typical waterfall environment, there would be a requirements gathering session. There would be a long design process, development, and a long QA cycle. Obviously, in today's world, you can't do that. But at the same time, you just can't put stuff into production very fast without it working. So the goal of modern development practice is get it in fast, but make sure it works well and make sure it's tested. Because if it's not tested properly, well, your customers are going to test it. And then your customers are going to test it one time, and then your customers are going to go somewhere else. And that's the last thing you want. And finally, you have to continually improve your system. And I say this more for the staff that you have, because if your staff is not motivated, that, hey, they're not building new things, if they're not enhancing their product, they're going to get bored. If they get bored, some people make mistakes, some people go, and some people do nothing. Those are all three things that you cannot have from your staff. Your staff must constantly improve. They must constantly find new solutions, better technology. Because if your staff isn't doing that, or if they're incapable of doing that, your business is going to suffer. The central tenet of the modern development or application modernization is the notion of microservices. Microservices is a structural and organizational approach to development, where you try to compose things into its smallest independent components. And typically these services can be owned by small self-contained teams. Why do we want to do this? Now, the goal for this is, if you have a small independent component, it can be tested quickly, it can be tested properly, and if it's not integrated as a giant monolithic application, I can push that change in to my production system as quick as possible, as quick as this small team can work in an efficient manner. This gives a lot of flexibility in your development environment. This gives a lot of flexibility for your business, because they know we have an idea for a service. You can now make minimal changes along with your microservices and maybe your customer engagement channels, and get your feature out without a large scale regression and testing cycle, which obviously leads to a longer time to get to production. And finally, may not, especially if it's in a large monolithic application, it may not be enough testing to give you 100% confident that things are going to work properly. And if you move to a microservice architecture, you should feel a much better comfort level and confidence that your changes were done quickly, but tested properly, and you can get your features out faster. So microservices are at the heart of a modern application development process. And just to recap kind of what I said, the benefits of microservices: obviously agility. Teams can move fast. Teams can get things in and out faster. And for those of you who run large production environments, potentially simpler deployments. You have a small component that doesn't need massive or large scale downtime to be deployed into production. Obviously, deployments of any kind, no matter how simple it is, especially in production, could cause issues that you're not aware of or you may not have even thought of. So simpler deployments means a lower chance of risk. It gives you better reliability and obviously gives you a better reputation. I'm going to skip flexible scalability and go to lower costs. If you've broken up your microservices into lower costs, that development cycle is shorter, your team size is shorter, and you can get more features out. Typically, if you're in a waterfall environment with a large monolithic application, you're going to have to pad, let's say any feature, you're going to have to pad some time onto that just because you don't understand all the testing and you don't understand all the complications of the development because it's a function of it's a monolith. You don't know everything. If it's a small microservices, you know pretty accurately that your team can go in and out and they give you a very good estimate. And pretty much you can take it. In an agile world, a good sprint planning, you can put a number assignment to it, and then you get a very, very good understanding of that cost, and more importantly, that time to get it into production. And now I'm going to come back to scalability. Microservices allow for scalability, operational scalability, development scalability, and basically personnel scalability, because now in a old school traditional monolithic environment, if I have a new hire development person, I could potentially put them into a BAU environment, try to get them to learn as much as possible, but that process is very long, very taxing. If I have multiple little teams, and let's say I wanted to bring somebody through a rotation, I could take that person through a rotation of all my teams in a year, and now that person pretty much knows your system very, very well. And after a year, somebody working in a legacy traditional development shop, they may not know, they may not understand that. And that goes double for an operations side. Operationally, unless you're running the applications day to day and you're running all the applications, you don't know how things play out, how things work. Microservices allows you the flexibility to learn and deploy and build and scale out as you need to. Old school ways of doing things, right? I have a service, I don't know how much traffic it's going to be. I need to get hardware, I need to get this, I need to scale it out for the max. Not anymore with microservices. Hey, well, it's deployed small. Hey, if it grows, if it's going great, we can easily scale it up. It's a small component, right? Either get a bigger EC2 or a more Lambda. It's a win-win for everybody. So at a high level, these services, these benefits bring the cost savings through the roof for organizations, both big and small. I've talked about this a little bit here, monolithic versus microservices. Monolithic applications, big, large legacy WAR files built as a single unit, deployed, singly, and then horizontally and vertically scaled. Scaling any part of that app means scaling the entire app. For example, let's say I have a billing function and a lookup function, and all of a sudden it's Black Friday. I need to scale the billing, the lookup function. Everybody's coming, everybody's looking for stuff. Wow, you can't do that in a monolith. You better scale out the whole thing. If you're in a microservice organization, hey, let's just get more instances and more resources for the lookup. And also, yeah, as I said before, as the monolith changes, the code base becomes much more complex. Changes become much more difficult to make, harder to test. And also the teams who are doing the changes, they have limited autonomy. And what does that mean? I used to work in a large scale organization. You bring in developers, they would be very scared to touch even one line of this monolith, because if they break it, they're going to get yelled at. Bark used to yell at them if they did. And really, it's not necessarily their fault. They don't understand how it works completely. You can't test it all. You just can't. Now that changes when you come to microservices. Microservices applications build a series of individual components. You can scale them individually. Changes are much simpler and they're confined to only their independent components. And you can, and let's say you have a large feature that has changes in multiple components, you can stage those components and get like a first stage in, test it, make sure it's working, and then get the second set of changes in on a different microservice, get them in working, and then change your front ends so obviously the customer can see it. Now, back in the old days, in a monolithic environment, if you tried to do that, you'd stage that over releases, and then you would drop code, test, then drop code and test and retest the same things over again. Here, you're not retesting the same things. The individual components are tested, they're working, your team knows they work. You move on, and that team is working on new features. And lastly, that team now has the authority and the autonomy to make the changes they need as they need to, because they're a self-contained unit. They control everything and they can build everything and deploy it on their schedule. And that brings the true agility of microservices that businesses require today. I'll give you a small example here of the traditional monolith and how it works. Customer comes in their browser, hits a storefront. They may be on-prem, they may be not on-prem, but it hits a load balancer. Load balancer hits multiple, hits a middle tier application or some sort of set of services, but they're all bundled together, hitting finally a backend store database. So typically, if you have to change something, you'd have to test literally the whole stack and everything. So it would be a situation where you as a business person, you're waiting for this change. I want a small change in account services. How in the world is it taking so long? Well, we have to test everything because it's all bundled together. While that business person complains to his boss, who complains to his boss and says, I can't meet my number because my feature is not there. Those are hard conversations. I've been in those conversations. You don't want to be in those. Moving to this microservice architecture, you can see how things kind of lay out at a much more granular level. Storefront UI, single component. There's a load balancer in front of the account service, cart service, shipping service. Each service has its own independent database. There's no cross connection. Let's say that same person wanted a very small change on the account service. It can be done, bang, tested, deployed out the door way faster than it was in a monolithic environment. It gives the team the flexibility to make the architectural changes they need. As long as the contracts are the same, the front end still works, hey, they can make the changes they need. It allows you to make technology decisions much faster. If you have a monolith and you're trying to change technologies, That's a long process. Good luck. Those take years. I was on a transformation project a long time ago in a galaxy far, far away. We took 2 years. We took 2 years, hard sweat, bones, bones breaking, fights in the parking lot. You get to the date, we deliver, but then business doesn't want it. That's an awful place to be at. That's an awful place to be at for a transformation, a technology transformation. Well, let's say I want to do that here with account service. I build it. I don't like it. I can throw it away. I have not impacted the whole organization. Potentially not. So microservices give you an opportunity to try out new technology much easier. Now, what are the central tenets that drive this microservice architecture? Containers and serverless. What are they at a high level? Containers, simple. It's a method for packaging that code to its minimal unit so we can run on so we can run either on a developer's desktop. A long time ago in a galaxy far, far away, a place Mark and I used to work at, we had a very large legacy system. We could not virtualize, at the time, we could not virtualize our test environment. We could not build it so our developers could work independently and give us code. Developer would look at the code, try to change it, guess it how it would work, but he can't really test it. He'd give it to us. We'd put it, and we'd have these deployment windows, and we'd put it in. And then the first test, it failed. So I've lost that deployment window, and I've lost all that test time. I've got to get a fix out right away or roll this thing back because I have a QA team testing, and they're blocked. But if I had a way to put that environment on this developer's desktop and let him work and let him test his code and have a little bit of confidence that his code is going to work and he's gone through his unit test and he checks it in and he pushes it out and we deploy it to the official environment. QA starts, hey, everything is working. Automated tests work, manual tests work. This feature is working. This is great. We're good to go. Containers allow that. Standard Docker, Kubernetes. We'll get into that a little later. The next big element, serverless. Again, back in the day, I have a new application. What does that mean in a data-centric environment? In a data-centric environment, that means I had to go like, hey, we need to build this new environment. We're going to host it. Okay, how much traffic is it going to take? Is it going to need this? Do I need hardware? Where is it going to run? Can I run it somewhere else, or does it need to be on its own hardware? Oh, we think it's going to be big. We may need its own hardware. Okay, what does that mean? What does that mean? I've got to make a PO. We've got to size it. We've got to make an order. 3 weeks later, 4 weeks later, hardware hits a dock somewhere. It's got to get asset tagged. It's got to be bailed. It's got to be racked. It's got to get IP'd. Application team's got to put the OS, and Unix team puts the OS. Application team puts their code. Now the developer's code goes in. Wow, that's a long process. That's a terribly long process. I've lived it. It's terrible. It's a long process for something that may work great or may not work great. On AWS, you have the concept of serverless. Let's say you run it on a schedule. We don't know. Developer writes some code somewhere. We check it in. Okay, we don't know how much traffic is going to get, but we know it works occasionally. 3 times a day, we'll want to run this thing. Okay, let's set it up so it runs serverless. That means we're not assigning specific hardware to it. It's about running your apps without thinking about the servers. And for people who have run data centers, that's a wonderful concept. So these are the two main tenets of microservice architecture: containers, serverless, and obviously AWS gives a lot of flexibility for both. Quickly about serverless. Serverless, it basically spans the entire category of services. Now, a lot of you already know this, but I'll quickly go over it again. Compute obviously is basically resources for processing, computing, data storage, obviously databases, storage related things, integration, obviously. There's basically pieces of code that allows you to bring one piece of information to another piece of information. So you could have serverless components that basically span the gamut of all the layers of AWS. By having that and getting you that level, it brings one efficiency right away, because you don't necessarily need to have dedicated hardware for it. It brings the cost down. It possibly gives you an opportunity to scale much easier. Secondly, it also gives you a chance to say, hey, I just need a developer. So if you're I've talked a lot about enterprise legacy setup. If you're a startup, this is the best thing for it, because a long time ago in the galaxy far, far away, if you're a startup, you had to go get those things. You had to get co-location space. You had to get servers. You had to put somewhere. But now you don't. You just need your code. If your code works, you're ready to go. Let's just focus on the two big elements for compute right now: Lambdas and Fargate. Lambdas, event-driven code. Like I said, I have an example. Think of the old style batch jobs. That's what this is, right? It needs to run at a certain time, either some kind of event or a schedule. Hey, it needs to run. It runs. The output is done, and then there's some sort of integration for the data or the output of the code. Like I said, in the old days, you had to find a place for it to run, and then you had to figure out a way to get it scheduled. I'm dating myself here, but products like CA, Autosys lived for a long time and years by just doing this function, being the scheduler. But now you don't need that anymore with Lambda functions. And serverless is really the way to go for event-driven code. You don't need to look at anything else. And finally, Fargate. Many serverless you need serverless components for containers. So it's a set of applications that run together, that's long running, that brings many pieces together, that has a sort of an orchestration. So think of it as a group of applications that run together. Say it's like the whole, in a traditional sense, the whole middle tier. If you've broken it up, you can run it as a serverless container. Now this slide is a little busy, but I will kind of give you the highlights. AWS gives you a lot of features, and back in the day, and then there's obviously things that AWS manages, and there's things that the customer manages, or you would have to manage. And as you basically move up the scale on this, the customer has to manage less and less. For example, let's say I have code, it's running on a simple EC2. What does that mean? AWS is just managing the physical hardware, the network, and the facilities. You, as the customer, have to manage the code, the integration, the scaling, the security, the provisioning, the management, and the patching. But you're not running a data center, and you're not responsible for physical hardware problems, which is a good thing. Next stage up, you go to EKS, containers, Kubernetes, container management. Basically, the orchestration is controlled by AWS, but you still own the code and all the integrations. Next, serverless containers, Fargate. AWS handles all the orchestration, the clustering, and all the physical things. You just worry about your code and your integrations. And finally, Lambda, basically, Lambda takes care of pretty much everything, and you just worry about your code. So depending on the situations, a lot of things can fall into Lambda, which is kind of where you want to be. But this adoption of microservices requires changes all throughout your organization and how you do things. Specifically, it requires a change in your CI/CD process. It requires a change in how you do monitoring. It requires a change on your real security model, your tooling for developers, and your service management. So going into microservices is not just there is huge wins, but you have to decide you're going to do it, and you're going to have to do it the whole way. And it changes how you do all of these things. But those changes, once you do them, will make you much more agile, much more flexible, and obviously much more responsive to your business needs. Again, another hugely busy slide, but think of it simply this way. Serverless microservices, you have a whole suite of tools that you can use. Serverless data stores, obviously database, DynamoDB, Aurora, S3 buckets, AppSync, the whole set of developer tools underneath, and then security tools that are required. It is an ecosystem for you to go into. But that ecosystem, once you move into it, and once you fully adopted it, will bring you the speed that you've never had before. So I appreciate you guys letting me talk for as long as I have. I just want to leave you with this. You have to innovate without the fear of failure. You can't have a developer sit there with a one-line change, scared to commit that code. If he is, you're not going anywhere. And you have to have a business person that has to be able to come up with ideas and be able to bring it to market fast in order to keep your customers, to keep your customers happy, to keep your business moving. And you have to have innovation. And you have to move into a modern application environment. If you don't, you will be behind. And like I said before, application modernization and Svitla, this is literally the bread and butter. We have numerous projects that we've done. We have numerous case studies. If there's one thing that Svitla is very good at many things, but this is the number one thing I can say. Application modernization on AWS, getting out of a legacy development environment, building a new, quicker way to get things working. Svitla is an expert at that. We've got 800 employees. We've got, I forgot the number of projects, but numerous ongoing projects doing that right now. And all of that means innovation. And without innovation, your business is going to die. So with that, I'll turn it over back to Mark.
Thank you, 𝐓𝐞𝐞𝐞𝐞. Okay, so we had a couple questions that have been posed. The first one was, in working with some of the clients you've worked with, what are some of the more pressing challenges they faced in the modernization of their platforms?
Okay, great. That's a great question. The first, there I would say two big challenges that a lot of customers face. Number one is the fear of trying to break up their application. Now, many large, legacy companies, they can't. It's hard to conceptualize because everything's been all together. you have to have a plan on trying to figure out like where the logical breaks to make those physical breaks. And then you also have to make that understanding of how those components work together. So once you've understood the logical components and you've made physical components, you need to figure out ways for them to basically merge together so you can basically put it on AWS in a way that is cost effective, but also efficient for your business to develop and go faster.
Okay. Why would I do a big bang approach over a slow rollout, and which is better in your opinion?
Well, yeah, I think to answer that question, I think it depends on your organization, right? If I'm a small to medium sized business, you may decide to go with a big bang. I wouldn't necessarily agree to it. The traditional AWS approach to a migration project, migration and modernization, is to analyze your stack, basically what they call the 6 R's. Figure out what you're going to do. Keep, rehost, replatform, retain, refactor. You have to figure that what you're doing first, and then kind of do it in a slow manner. Because if you do it in a slow manner, it allows you to basically see how things work, gain experience as time goes by, and it gives you I think a little bit more reliability at times. So for a lot of organizations, I think the slow roll is the better way to go.
Okay. What are the skill upgrades I need in my existing tech workforce to be able to get the investment in this to work?
That's a great question. Your people have to change, right? And a lot of and I'll go back to legacy large enterprise shop. Typically, you fall into two categories: people that have been doing the same job for a long time, they're good at it, and people who are been doing the same job, but they're kind of, itching to do something else. This requires a move to the cloud requires basically all people, whether it's development staff, QA staff, operations staff, PMO staff, business, to change their mindset and basically fundamentally learn how to work in the cloud. That requires a skill upgrade. That requires basically people to get, if you're an operations side, basically get, certs, knowledge upgrades on how, what on-prem was to what operations in cloud looks like. For development, obviously it's the mindset change. You have to sort of start thinking in a cloud native centric way. Even from a PMO standpoint, when you're basically onboarding projects or working in a Scrum environment, it changes how you conceptualize work. It changes how you're organizing work and organizing money. So in every aspect, your people need new skills, but their base is still going to be the same. But it's not like it's a, it's not like you're learning a new language here. It's just, it's an enhancement of the skills that they already have.
Okay, last question. Most CIOs, CTOs have to work within capital budget dollars. So we have to decide between what we're going to spend for new features versus making a case to the business that we need to do a modernization project. What are some reasons or ROIs they should investigate so that they can make a compelling business case to their financial officers that they can invest in modernization?
Wow, this question takes me back a long way. For most CIOs, budget dollars, you're not going to get budget dollars to rewrite your existing code. Nobody's going to give you money for that. And why should they, right? I got something that's working, build on top of it, right? But the key here is looking at your ecosystem as an ecosystem, and figuring out places where you can cut and move, cut and move, cut and move. And I'm not saying move, and I'm saying move to the cloud, not just move to the cloud, but modernize the pieces. And it goes back to the 7 R's conversation. Any CIO, any CTO is always looking at their application suite, and they're always should be looking at this, and they're always asking these questions. Hey, do I need this? Do I need to refactor it? Can I move it? Can I modernize it? How do I modernize it? And over time, you should be modernizing it. You should be modernizing it, but building the new features in the modern setup. So you're never going to get a large chunk of money. And I would never ever tell anybody, say, hey, go get a $2 million, $3 million project. Let's get it started. Let's rewrite everything. There's no point. It's pointless because you haven't put any new features in. Cut, make a plan, figure out your pieces, and figure out how you can migrate these individual pieces over time into AWS on a modern stack. That's the way I would kind of contemplate it. But it requires a real thought process and sort of a deep analysis of not just your application staff, but your people, because it's a process. I hope I answered that question.
Yes, we appreciate the answer, T-Boot. I'd like to thank everybody for attending. We'll leave the line open for a couple minutes if you want to drop your contact information, or if you had any additional questions, or you wanted T-Boot to follow up with you. Please feel free to drop information on the chat, and we'll get back to you as soon as possible. But again, once again, thank you for attending, and hopefully you found the session useful.